Hello, everyone, and welcome to the Metadata webinar offered to you by the RADx Data Hub Partners. My name is Susan DeBleek, and I work for the Renaissance Computing Institute at the University of North Carolina in Chapel Hill. We're really excited to welcome you to another RADx Data Hub webinar. We're thrilled that you've joined us to continue to explore the possibilities of the new National Institutes for Health RADx Data Hub, where researchers can search over 125 RADx studies. Feel free to update your name in the participants list. You can click rename and add your organization. Let's begin. This webinar provides an overview of metadata. For today's webinar, we will be using the question and answer function in Zoom. Please use the Q&A function to submit questions for our presenters and Data Hub partners that will be included in the Q&A. We hope to get to your questions at the end of this session. That said, today's agenda includes a presentation by Sarah Meyer, also of the Renaissance Computing Institute, a question and answer session with our presenter and Data Hub partners, and we'll close with a few resources. And so to kick it off, I wanted to ask John Graybiel of Stanford University, one of our esteemed RADx Data Hub partners, to say a few words about the RADx Data Hub and today's topic of metadata. Welcome, John.
Thank you. Sorry, I'm not visible. There we go. A little more visible. Really appreciate everybody coming for this presentation. And I want to encourage you all to be looking forward as you're hearing these topics that are very dear to our hearts on the Data Hub. We are looking to make the RADx Data Hub a model of handling of metadata and of harmonization. And it really depends on a lot of the principles that you'll hear about today and on getting everybody who's in the Data Hub community and who's thinking about submitting data to the Data Hub to be thinking along the same lines of how can we easily create metadata and make it work well for the Data Hub systems. So have a great presentation, and we'll get opportunities later on beyond this presentation to start going into more details about how these things can be applied and can be used for submitting data, not just to the Data Hub, but in other environments. So we can look forward to that in the months to come. Thanks much, and back over to you, Susan.
Thank you so much, John. Now we'll hear from Sarah Meyer. Sarah Meyer is a data steward at the Renaissance Computing Institute at the University of North Carolina at Chapel Hill. Over to you, Sarah.
Thank you very much, Susan. And thank you to the RADx team for the opportunity to present on metadata today. So this webinar is meant to be a high-level overview of metadata and its relationship to the FAIR guiding principles, to data model methods, and to data harmonization strategies. Data represents people, it represents ideas, and it represents research innovation. And well-curated metadata is an essential tool to organize data and to find connections between different data sets. And another way of looking at our objectives is to kind of look at it along this continuum, that we need rich, well-curated metadata. It needs to adopt FAIR principles. There needs to be solid and good metadata and data management practices. And when you have those, you have the ability to unlock value and to encourage discovery, persistence, and innovation. It can facilitate more powerful analysis with larger data sets. It allows for secondary data analysis. It allows for data reuse. It can be a really, really powerful tool for interpretation and for discoverability. So well-curated metadata and detailed metadata is really an essential tool for describing investigators' data sets. Metadata at its core, in its simplest form, is a description of your data. It is data about data. It provides context for that data. It should be able to be read by a human or a machine, and it should also be potentially findable and usable by other researchers within the RADx project or within any other project. And for this webinar today, we're going to focus on RADx. It can assist in finding and organizing and using information. And one of the other pieces about metadata is that it may be the only communication that occurs by whoever creates the data and anyone else who reads it or any machine that interacts with that data. The NIH Data Management and Sharing Policy, whether it's the 2020 or the 2023 update, includes the following description of metadata. It is creating data that provides additional information that makes scientific data interpretable, interoperable, and it also makes it reusable. The NIH requires a data management and sharing plan, which outlines how scientific data and its metadata will be managed and shared. It also encourages researchers to maximize the appropriate amount of scientific data that can be shared, which often includes metadata. Within the RADx project, there are multiple different types of metadata. So there's study level metadata, there's data set, and there's variable metadata. Often this can be machine readable, and it's often hosted into a repository. There are also community standards metadata, and we are going to discuss those specific types of metadata later in the presentation when we look at these ideas of data modeling methods and harmonization. One thing to point out is that this graphic was adapted from the HEAL initiative, which is helping end opioid abuse long-term. It is one of the projects that I sit on as a data steward. But there are a lot of different types of metadata that are shared between different projects. And so this was one graphic we adapted, and it is specific to the RADx project, but you will find that metadata, regardless of what project you work on, there are a lot of similarities that cross different projects. Within study level metadata, it is specific information that describes the study. It is something about the study's name. It often gives a description of the study. It talks about who the investigators are, and it may include a unique identifier. This metadata allows searches within larger data collections where other researchers can actually easily find and read details about individual studies. Within studies, there's data set and more specifically variable level metadata. And that variable level metadata describes information about very specific data elements, whether the name of the data element, the description, the type, format, or the source. Every single variable has significance. And this is also the level at which most machine readable metadata descriptors are created. So it needs to be detailed and accurate metadata so that it can be easily searched for by people, by machines. And this actual type of metadata has some very specific relationships to RADx in that some of these variables are what we call common data elements. So common data elements, or more commonly called CDEs, are extremely powerful tools for connecting between studies. Because they are standardized questions that are used across sites and studies and clinical trials, they are very, very precisely defined, and they have a set of responses that are paired to that definition. And so this coding that is done specifically so that it can be searched by a human or by a machine, and it also ensures consistent data collection. And this is important because if you have multiple studies that use the same common data elements, then you can combine those pieces together and create a new data set. This allows for cross-study comparison, it allows for secondary analysis, it allows for more robust or power analysis, and it accelerates joint research. One thing to point out about this graphic here particularly is that CDEs do not exclude specific study-specific data from being analyzed. You could also include study-specific data from study 1 and study 2 into your new data set. It just means that the combined data set of the common data elements are going to allow for more efficient and more powerful analysis without having to do any data cleaning or harmonization. Within the RADx project, there are 3 specific types of CDEs, and they are at different tiers. There are links here at the bottom of the presentation that will give you some more specific information about the tier 1, the tier 2, and the tier 3 common data elements that are associated with the RADx project. There are also additional resources around metadata specifications, and there will be more information coming out about 2 specific tools, which are the CEDAR, which is a tool for managing metadata, and the BioPortal, which is a tool for managing controlled vocabularies, which we'll be going over later. So well-curated data, when it's created, whether it's at the study level, the variable level, or the community standard level, can enable the use of the FAIR principles. So what is FAIR? FAIR stands for findable, accessible, interoperable, and reusable. There's a gofair.org website that represents a leading organization that provides detailed information about each of these FAIR principles. And we're going to so one of those, the first of the FAIR is called findable. And so findable deals with unique identifiers that are globally unique, meaning that you can only find them once, and they are going to be always associated with that piece of data. They are often registered or indexed, and they are extremely, extremely important for non-text-based data. So one example we see of non-text-based data is what is called the DICOM header. It stands for the Digital Imaging and Communications in Medicine Standard, and it specifies a data interchange protocol. It specifies a format and a file structure for biomedical images and image-related information. The DICOM standard is not proprietary. And so that's important because whenever you want to use something that is findable, you don't want it to be proprietary. And it includes specific information about the information and the image that will make it searchable. I should also point out that there are advances in emerging technology that actually allow images to be searched directly, both by humans and by machines. And so it's going to be really interesting to see how that will impact metadata going forward. But for right now, we have a lot of different machine readable tools that will let you read header information like DICOM. The next point of the FAIR principles is accessible. And the point to be made here is that accessibility is not that all data should always be accessible to everyone, but rather that whoever creates the data is allowed to provide the conditions under which that data can be accessible to other people. So metadata should also be in a common format that can be read by human or machines. And so that's really the point of accessibility. We also see it specifically with what we call DOIs, or digital object identifiers. These are very, very unique assigned numbers that are set up by different organizations or by a repository, and they can be assigned to different types of data depending on where that data is stored. It can be applied, as we often see in published articles, but you can also have DOIs assigned to data sets and to study protocols. The next FAIR principle is interoperable. This allows you to create meaningful links between metadata and data. It may reference other metadata so that it can be cross-referenced and you can find it in other sources. This is where we see the most connection between reusability, harmonization, and other pieces that we're going to cover later on. But interoperability is also demonstrated in that it can be read by machines. And there's one specific project that is working on this within the RADx project. This is one resource. It's called Metadata for Machines. These are short workshops that bring together domain experts, metadata experts, and tooling, and they create specific templates for a specific community or a specific group. So why make metadata for machines? So it's easier if the machines can do the work to get the data ready for analysis, or what we call AI ready. And so the M4M group is making it easy for humans to make metadata for machines. The final principle of the FAIR is the R, which stands for reusable. Metadata should be reusable. It should have a provenance, which is actually one of my favorite words. It stands as a historical record keeper. Where did this data come from? Has it moved between databases? Where is it now? And as well as, does it actually meet community standards so that you can actually use this data by the other places. So once we have fair metadata, we can need to see how it should be included within our data models. So what is a data model? Data modeling is done to inform data analysis, whether that's primary or secondary. And it's important to think about metadata and how it affects to a data model. It often provides a blueprint for how that data is connected from the data collection process through the final analysis, and is dependent on the relationship between the types of data and the relationships within that data. It also will include specific tools that will connect data to other data, and it may involve something in the same data set or things that are outside of it. And so for today's webinar, the focus will not be on structural study data models that may be applied to an industry or a field of study. So we're not talking about hierarchical or relationship or entity relationship data models, but we're going to focus on data model methods that apply specifically to metadata creation and tracking. So where metadata and data modeling meet is that ideally investigators map their variable level metadata to community specific standards or data models. So this is going to show a connection or relationship between metadata and data. It is going to map data sources or components to its associated metadata. It will combine codebooks to data sets. It connects to community basic and community specific standards. One of the most simplest forms that we see this in is what we call the README file. It's a plain text file. It's meant to be read by humans. It's used to be assist into interpreting a data set and its intents and limitations. There's quite a few different pieces that can be included in this. This sort of file is often required if you submit data to a data repository or if you are sharing data sets between teams or team members. One thing that I will say, if this is not something that you're familiar with, there are a lot of resources that exist out there. Whether if you're an institution, you may have someone who sits as a data librarian or a data steward, and they are able to provide resources for you as to like how to create files like this. So there's definitely a lot of resources for you. There's some great universities. Cornell does an excellent they have a great tutorial here at the University of North Carolina at Chapel Hill. We have an entire tutorial that you can go through online. We've seen some great work outside of the University of Oregon. So if you're within an industry or outside of an academic institution, you should also have data managers or other people within your area that should be able to help you build files or to find tools to create some of these within the different data models that we're going to discuss. So the README file is read by humans and it kind of stands alone. The other types of data models that we're going to talk about fit within this idea of a community standard. So as we've already discussed, there's the common data elements, and then we're going to take a look at things that are called a codebook, a data dictionary, controlled vocabulary, and an ontology. So data dictionaries and codebooks are basically the simplest form of collecting variable level metadata, often within the community standard. They can be created to be read by humans or machines. They will describe individual variables in detail, whether it's the structure, the content, or the meaning. Some people use codebooks and data dictionaries interchangeably. I see them a bit differently. I've included the National Library of Medicine. Their data glossary has a great explanation of that. And if there are any data specific terms that you have questions about, they're also a great resource to go to if you're looking for what is a standardized definition. Where I see the differences between a codebook and a data dictionary is that codebooks are more likely to include questionnaire data that is read by humans. They're often built by humans and they speak to specific questionnaires, and then you build out different codebooks based on the questionnaire or the type of data. Data dictionaries are often built out on any type of data that sits in a study or a project and is being readable. If we take an example of that, this could actually either be a code book or a data dictionary. This bottom one actually comes from a CDC code book that I used for a previous project. But what you'll see in any code book or data dictionary, there's generally a variable name. It will tell you about the data that you're creating. It will give you a label. It will talk about a variable type. And this expected value is extremely important when we get into the concept of data harmonization. It should also, if it's in a questionnaire form or other piece where there's multiple choices, you're going to see variable level metadata that's listed in your codebook or your data dictionary, and it will often tell you if that data is open-ended or not. Controlled vocabularies are kind of a step up. They are used as a community standard, and they set a set of unique identifiers to classify data and information. They are very, very specific to a community, and that community could be a study network. It could be an area of interest. It could be related specifically to a funding opportunity. It could be related to a publisher or some publishing guidelines. And what you'll do is you'll tag this data with the controlled variables, and it creates a framework for sharing data within that community. And it also provides a very specific definition for anyone outside of your community who is looking at that data. So one example is what we see with the mesh descriptors. So these are medical subject headings. They come from the National Library of Medicine. It's controlled vocabulary, and it's used for indexing articles in PubMed. So mesh descriptors are pretty common controlled vocabulary that is used for meta-analysis and secondary analysis and trying to find specific words or even trying to find articles around a specific topic. But these serve as one example of a controlled vocabulary. Within that, we also have ontologies. For some people, controlled vocabularies and ontologies are the same thing. That's fine. For me, I definitely seem to define them a bit differently. Ontologies, for me, talk about the relationship between concepts. Sometimes you will see controlled vocabularies and ontologies in the same sentence. For me, I split them out. So for ontologies are going to talk about concepts. They are still built within a controlled vocabulary. They will also have unique identifiers. Just like a controlled vocabulary, they are standardized to whatever community it's represented by, and they increase the interoperability of that data and the metadata. Two ontologies that I have seen in RADx funding, it should be the Mondo disease ontology is one, and the human phenotype ontology are two examples that I've seen in the RADx project. There may be other ones. So what we know is that metadata is also an essential tool for data harmonization. So once you have your solid data, it's applied to the FAIR principles, and you have solid data modeling strategies, then we can begin to take a look at data harmonization. Where we see data harmonization is that it's a process to combine data from different sources. It will include specific information. It often creates a new data set, and it increases the potential power or scope of data analysis. The ICPSR that we have here, their data repository really has an excellent guide, an example of publications around data harmonization. They're on the 6th edition of their guide. So if this is not something that you're really familiar with, they're a great place to start. The RADx project also has resources, and you will be able to find information. Within metadata and harmonization, one of the really key pieces is that it helps identify potential fields for you to harmonize or to combine data sets. It also informs the process because it tells you what is possible, what is not possible, what may be easy, what may be difficult, and it defines the limitations of what that could actually be if you want to do a secondary analysis. And so one example of that would be when you want to take a look at some if you're going to pull in a project, you're going to need to take a look at both the variable level metadata, and this may also include having to take a look at the administrative and the technical metadata that is associated with a data set. This isn't always there, but if you have access to it, it's extremely, extremely helpful. Administrative data can tell you if it has actually accessed any like CMS data sets. How did it clean it? What did it do with that? It will also, if you have technical metadata and you're sharing between multi-sites, it can say this project combines sites from these regions in this way, and this is how they combine their data sets from pulling from here, or from this is how we pulled information about wastewater, and then this is how we pulled it from here, and then it will tell you how it combined it. And that can be really extremely helpful if you're looking to do any power analysis or secondary analysis, because then it may actually also inform how you do that analysis and how you even connect with partners or partnerships if you're looking for future analysis. Often it will create new metadata. And so that often means that you may have to go back and consider different variables or consider different analysis methods as you harmonize the data. So a very simple example is if you want to harmonize by an age variable. So if you have study 1 here and you have 120 people and they collect their age by a range. And then if you have study 2 and they collect age as a number, if you want to harmonize this data, there's going to be a couple steps. You're going to need to recode study 2, and you're going to need to match the age variable and break it out into an age range and give it a new variable type name. And then you can eventually merge those two age variables into a new variable, which we called age harmonized. But now instead of 120 or 380, you now have 500 people that you could run analysis on. And it's not just limited to this age variable, but this also allows for power analysis or secondary analysis using this with regression or with other information. And so that it will allow for a general, more powerful analysis as you're looking at data sets. So metadata is built for discoverability, interpretation, and data use. Well-curated metadata is an essential tool to organize data and to find connections between data sets. It allows you to work with bigger data sets for more powerful analysis. It allows for secondary analysis. It allows for innovation and discovery, and it allows you to reuse data and to apply it to different conditions and even in different environments than that data was initially intended. So at this point, I'm going to turn over the presentation to Rob Hubble of the University of North Carolina at Chapel Hill's Renaissance Computing Institute, and he will facilitate our Q&A session.
Thank you so much, Sarah. I have a few questions here. I know that in the Q&A, our folks from Stanford, John and Matthew, are answering some of the questions right there, but I'll just bring it up and let them answer as well. The first question was, will we implement ISO standard on metadata that establishes the basis for FAIR? John, I know you typed an answer in, but if you want to elaborate, that would be great.
Sure, happy to. Sorry, just lost my visual. There we go. FAIR, as Sarah outlined, is a set of principles. And by the way, Sarah, great job. Thank you very much. Before we get away from that, it's a set of principles, somewhat vague in some cases, in no way concrete enough to be directive or measured themselves. And there are a number of different initiatives that are attempting to make FAIR more measurable, to metricize it, if you will, and be able to evaluate how fair particular metadata is. Some of the principles apply to the metadata, some of them apply to the repositories that hold the metadata. So that's a complication. I don't think any of the initiatives to date are contemplating ISO status. I think we're a level of precision and rigor away from that, at least maybe 2 levels. But we're definitely interested in how fair our metadata can be. And when we built the tool, we naturally made it pretty fair to begin with, and we'd like to make it more the tools that we're working with, like CEDAR and BioPortal. So we're definitely looking to do a good job of making the RADx metadata fair, and the tooling and processes that we use encouraging more fair results. And the exact shape that takes over the next year or two, we're going to have to see as we go. But I think we're off to a good start.
Next question has to do with machine readable or machine processable. There was an attendee who commented that data dictionaries might come in PDF format. And is that considered machine readable in some sense? But maybe let's expand that a little bit to other kinds of data that might be out there, and what limitations you see already, and what benefits will come down the road, we think.
I would just start. I think there were a couple of interesting comments that followed that that people might want to read in the Q&A in the answered section. The short answer from our standpoint is, as someone answered, is no, not really machine readable. That a lot of the reason we have for creating these specifications is to move beyond what is presented in a PDF, which is almost always human-centered, and to make things much more precise. Those are my thoughts. Matthew may want to add to that.
Yeah, I can say something. So, I mean, all of these documents, electronic documents, are machine readable in some sense, right? But as John said, PDFs are meant really for human consumption. And what we're doing is creating a data dictionary format that's easier to parse, and that has a precise specification for listing variables in a data dictionary and describing them in a semantic way. And that specification will be coming out soon. And all of the studies, data files will have data dictionaries accompanying them, so that the data dictionaries can be easily parsed and interpreted in a specific and precise way.
Since this is a RADx presentation, John and Matthew, just to talk briefly about the work that you did. It's been a very manual effort. You've taken what you can, and you've automated the process as you can, but you've done a lot of work to create code books and templates for this. Is there just to give the audience the perspective of how much there is, and how nicely the standards are there for them to start creating new metadata for their data sets. Maybe you could just elaborate on the work you've done.
Hey, Matthew.
Yeah, so we've got a few specifications out there, and I guess the two main specifications, the data dictionary specification that I just mentioned. We're currently in the process of getting some feedback from our DCCs on that and incorporating this feedback. And what we did with this data dictionary specification was we looked at about 120 data dictionaries that have been submitted, all in different file formats with different information in them. When we looked at core information from these and the kinds of things that needed to be captured in order to generate this common, well-defined specification. So that's there. And we've also got a metadata specification that's documented in a kind of in a programmatic form as a CEDAR template, and that's available in the CEDAR software. And we've also got that documented in a manual that people are following to create their metadata. And this produces metadata that's in a JSON format, so it's easily parsable. And moreover, it's JSON LD, so there's precise identifiers in there, precisely defined identifiers in there for describing what the actual metadata is for.
think it's fair to say that the way you just answered that, Matthew, addresses the next question in the Q&A, which regards harmonization. The question was for RADx, how much pre-harmonization has been done by, for instance, or will be done by data coordinating, the DCC, and are you, how well described are the data and the structured readable dictionaries to allow this harmonization to take place?
I'd definitely like to add some thoughts there. Each DCC is very different in the amount and types of harmonization they have brought to the data that they provide. All of them had to provide a certain set of core data, 130 or so variables, if you like, or CVEs, in a harmonized way to the data hub. And so for all of those data values, the data has been pre-harmonized, if you like, by the DCCs. That said, there is a lot of data that is not in those core variables. And so there are two things going on at the same time. We are emphasizing the value of describing the data via the structured machine readable dictionaries. And then to the extent that's done by the providers, we can start to perform analyses, some of them automatic, some of them manual, to determine which of those values could be potentially harmonized in a more systematic way going forward. Ideally, this would be done at the very beginning of the project, and we're now 2 years into the project, so a lot of this has to be a little bit ex post facto analysis and correction. And through the course of the coming year and years, we'll be working on how to best do that with the data that's already arrived, but also providing direction for submission of future data so that some of that arrives in pre-harmonized form as well. Realistically, I think we will be looking to provide as much information as we can describing the data so that people can harmonize it according to their needs as well. We should mention that in many cases, people are providing both their raw data to the data hub and also what's called the transform data, which is harmonized. The 132 variables we described are harmonized. And in those cases, it gives people the opportunity to go back to the raw data if they think something may have been over-harmonized or some information might have been lost. So there's a number of different paths that people will be able to take with data that's in the RADx system.
So a few more questions. There was a question, might be a term you used, Matthew, I don't recall now, but on power analysis. What was that? Is that related to the data collection or analysis of existing data?
I
That might
think
be
that was Sarah that used power
Sarah,
analysis.
did you say that?
It's probably me. So my background is in translational human subject research. And so we often look at ways to both look at new data sets and at existing data sets in a more expansive, I don't know if aggressive is the word I would use, but definitely a more definitive way. And so we will do a power analysis both if we're thinking ahead of a project and we actually think about that ahead of time, how can we scale up that analysis from our base level? That's one way we think of power analysis. Or if we're taking a look at secondary data, then we are looking at what are different ways, often with regression, that we can take a look at data in a completely different way that may either provide information to the field or may provide information to the team so that it can be used in a larger setting.
We need more power on our RADx project, obviously. Another question that is here is when will the RADx metadata be available to use? And I think the answer is there's some available already for those who can get into the data hub. Is that correct?
Yeah, that's exactly right, Rob. So if you've got access to the data hub and anyone can get an account and sign in, they could you can browse through the studies and see some metadata in there. We are currently in the process of adding metadata for different studies, so different DCCs are at different points in this process. But for studies that don't have the metadata, or data sets that don't have the metadata at the moment, it's coming soon.
Yeah, it's worth mentioning, just so people aren't surprised, that providing metadata with the data was not required in the first round of data submissions for RADx. So we're playing a little bit of catch up there. We believe for a large percentage of the data sets, we will have at least some meaningful data set level metadata. For all of the data sets that are in CSV format, we will be able to use the names of the variables to let people search on variable names. And then where we have additional information like data dictionary information, over time, we will be improving the interfaces so that the information in the data dictionaries can be searched for finding data sets of interest. This will be a progression over the coming year, let's say, to provide more and more features around the metadata and the capabilities of the system.
To put some numbers to this detail, I believe there are something like 130, I think you might have said this number, 130 elements in CDEs. So across all the DCCs, so across RADx, there's roughly 130 elements that somebody who has access to the Data Hub can go in and search for two different data sets from two different places. Supposing get access can try to merge those and those roughly 130. Is that a true statement?
That is true, but is not complete. The people can go in and search for any of those CDs by the variable names for the CDE. They can also search for the variable names for any of the other data fields that have been provided for the data submissions that are available. And so even the strange variable names are searchable, recognizing that at the moment it's just the variable names. So if the variable name is T7 special 123, you may be out of luck to understand exactly what that variable is until we have the data dictionaries correlated in to provide more explanation of what the different variables are.
We do have one more question. I want to mention, though, that for those of you who would like access, who are researchers or part of the RADx community, if you have questions about how to access the Data Hub, let us know. Let us from the engagement team, and we'll get back with you. And we have some other materials. There's been other training materials that will be helpful. There's a question about README files. I'm not sure how prevalent they are within RADx. So Don and Matthew may answer that. And then just in general, Sarah, you might want to talk to the README files that you've been using and how much quality control is being done on them. I'll turn it over.
There, some of the DCCs, I would say very few at this point, have provided README files. Some of the original ones that provided have since been turned into more precise, following the specifications, metadata files. The README files that are provided can be in different formats and including HTML, and are not provided for most of the data sets being received by RADx. So we are encouraging that information to be provided in the appropriate fields of the metadata that's following the metadata specification, so that people can access it computationally as well as through the computer. But we don't, if it's just a README file, as with other what we call auxiliary files, we do not provide any additional quality checks on that information, other than to make sure they don't include any personal identifying information.
a question about dbGaP. dbGaP provides data dictionaries for most of its studies in machine readable format, but they don't seem to be such dictionaries within RADx, associated with RADx studies. Shouldn't they be available?
We would love to make them available. As it stands, we are not always getting data dictionaries for all of the studies. And in particular, we've been focusing a lot on data set, metadata, and data dictionaries. If there are studies that are in dbGaP that are also in RADx, and there is data dictionary information about those studies in dbGaP, then we would like to mine that information and bring it over. Yes, we would definitely like to make that available. I don't believe we have done that to date, and I have to be a little careful here because I didn't develop the system and I don't want Joe to yell at me later if I have that wrong. But I'm not aware of it.
Just add something here. So I took the question from Ian to mean, why aren't these data dictionaries available in the hub, in dbGaP? The data dictionaries at the moment are only available in the RADx Data Hub. And there's plans we'd like to make these public, but I guess we're just waiting for some sort of clearance.
And finally, there was a question about contact information. So we will be sending out details to everybody who's here, who's participated. There's an email that Susan, maybe I don't think it's
Yeah,
been
this is a
posted
fantastic segue if you want to jump to the next slide. A big thank you again to the NIH, to Sarah Myers and Rob Hubel of UNC Chapel Hill, and John Graybeal and Matthew Horridge of Stanford University for helping us better understand metadata. And thank you all so much for submitting so many fantastic questions and participating in this webinar today. We want to know what you thought about the presentation. Please complete a short survey. You'll see the link here in the chat box. And just a quick reminder that slides and recording will be shared with the webinar registrants. Here's a list of 5 resources. I love that the question segued perfectly into this, and I would suggest the second resource, the third resource listed here, the Contact Us link, and we can copy that and put that in the chat box as well. So here we list out the comprehensive RADx Data Hub user guide, the Data Hub help desk once you are logged into the system and have any specific questions, the Contact Us form, which is more general for questions, and also we have a list of frequently asked questions and a list of upcoming Data Hub events. And just again, thank you so much for participating today. We hope that you do provide us feedback on the survey link, and we look forward to connecting with you all again soon, whether that's through a help request or at another upcoming event. So we can jump to the next slide and close by saying thank you so much for taking the time today to participate, and thank you for all that you do as researchers. Have a fantastic day, everyone.